Let's start with leading edge erosion. So, new article off the web today, or not today, but this week, about nickel-cobalt tiles. So this technology has been around for a little while, but they're just now trying to apply this to wind turbines, right?
Right. It's something we've used on airplanes for a long time, or something very similar. Anytime you have any rotating device, or anytime you're going to be impacting a lot of ice, mostly ice crystals or water particles, on a structure that you care about, on a propeller, wing, on an airplane, they're going to use something pretty robust, particularly propellers. So most propellers have a nickel leading edge, and helicopter blades tend to be something very similar. Propellers not as robust as helicopters that way, but propellers have this nickel leading edge, and what it's there for is to stop erosion of the blade. And it looks like ORE Catapult, which is Offshore Renewable Energy Catapult, which is based in the United Kingdom, has been doing some rain erosion testing and comparisons of different kinds of rain erosion methodologies, the techniques, materials, the whole thing, because they have a lot of wind turbines offshore, obviously, and they're trying to find a good solution. So they've been publishing some papers recently on nickel cobalt, and what it kind of looks like, Dan, did you think it looked like shingles in a sense, of like these little sections that are kind of glued onto the blade?
Yeah, it looks like, I mean, they refer to them as tiles. So
tiles.
Yeah, it seems to be that way. Mm-hmm.
Yeah. So it's a bunch of tiles that get kind of glued on, and I'm sure that they've done a lot of testing. So the testing indicated they had done 85 hours in a rain erosion test facility
At a higher speed, and it did well, versus 15 hours at a lower speed. So they said that there's definitely some erosion benefit.
Yeah. Well, the faster you go, right? It's one half. I'm going to throw you an energy equation: one half mass times velocity squared. There you go. So as you go up in velocity, it actually squares the energy. So going up a couple of miles an hour actually does a lot more damage. So you double the velocity, you quadruple the energy of each impact. That adds up. So it doesn't take long to really increase the energy. So going to a higher speed obviously is a lot more conservative.
So why that specific material? Like, you don't hear about nickel, at least in the consumer market. Obviously, like the commercial market, you hear, I'm sure there's a lot of different technologies, but in the consumer market, you hear of things made of copper. When they need to be durable and resistant, you think of stainless steel.
Yep.
Like, what's the deal with nickel cobalt?
It's hard. It's really, really hard. It takes a lot of abuse before it starts to give way. It's just a really hard, durable material. And what I mean hard, it's got pluses and minuses. When you deal with hard materials, it's hard. It's very difficult to form them into any particular shape.
Less ductile, ductility.
Yeah, they're high resistance.
Middle school.
Yeah, so they're a high resistance material electrically. They can be kind of on the brittle scale, more towards brittle than flexible. Like copper's very pliable. Nickel doesn't tend to be that way. But that's why they coat things in nickel a lot of times on aircraft parts, the things that are outside, like around the landing gear and that kind of thing. They can get nickel plating on it because it's a very hard material.
So they form it with a more malleable material and then just plate it with nickel.
Right.
Yeah, that makes sense.
Yep. So that's the same kind of thought here. Now the cobalt part of the nickel cobalt, I thought was interesting because I thought we were trying to get away from using cobalt so much.
It's a little controversial. People are getting killed over it, and it's still a conflict mineral, right?
Yeah, it is in some places. So that's why they're trying to get rid of it in batteries. Yeah.
It's got a great color though, cobalt. Just a superb bluish color, right?
Yeah, I guess it's cobalt blue is a cool color, but
it's a really good color.
Is it worth dying over?
Not worth dying over, but it's a great color for an element. Yeah. So they use these on airplane propellers. So why has it taken so long for them to put something metallic on the edge of a wind turbine blade? I mean, wind turbines have been around for 20 plus years. Like, why is this a new idea now?
I don't know if necessarily it's a new idea. It's more of how desperate do you have to be before you get to some solution like that, because you want to try everything else. You're trying to do it less and less expensive, more manufacturing friendly design than nickel cobalt would be. So putting on tiles I'm sure is going to be labor intensive, and I'm sure it's going to be expensive, and I'm sure it's going to run into problems versus just spraying on a more durable coating. If those are your two choices, you're going to go to spray on coating versus gluing something on. That's what's happened. And so until the spray-on coatings show that they don't last as long as in theory as they were predicted to last, you don't get to the next stage. It's just like anything else, right? You try it, you see what it works. If it doesn't work well enough, then you go to something that's more extreme. That's what they've done.
Let's back up. So what is the typical leading edge composed of, also off the factory floor?
It depends on who's manufacturing. It was just talk very generic and simple terms. It's basically just
what I want. It's what I want.
It's basically the same kind of coating that they make the blade out of. It's going to be some sort of resin system with a painted coating on it. Sometimes they'll add another pliable coating to it. The ones you see out in the repair world where they've gone out and repaired blades on the leading edge of blades, it tends to be kind of a coating that they've rolled on with a roller. So it's just another sort of thickened paint or polyurethane-ish kind of thing. I think was it Polytech and or Siemens Gamesa were doing something similar last summer where they were putting on basically these polyurethane erosion materials. It's kind of a real thick plastic, rubbery plastic. It's used on airplanes all the time, and they were applying it to the wind turbines just to absorb the rain blows. Yeah, that's from just the simplest forms. That's kind of what you see. Either some sort of spray-on, rub-on coating, or a polyurethane sheet that's applied to the leading edge. Yeah, simple.
So is putting metal on the edge of these turbine blades, is that going to be a lightning nightmare or what?
Yeah.
So just sum it up, just nightmare.
It's going to be fun. You got two problems. You got static charge buildup, and then you have the lightning issue. So it's a piece of metal hanging on a blade. Yeah, it's going to attract lightning. And how are you going to ground all these tiles? I don't know. You're going to have to figure out some way to do that. And it isn't like you can connect to nickel very easily. That's one of the problems with nickel, is that nothing really sticks to it. That's why you use it, because things don't stick to it.
So what do you mean stick?
Adhesive or solder or bolt things up to it. It's just not a material. It's kind of like gold that way. Like, it's a metal that doesn't like to bond to anything else without going to extreme efforts. So that's the problem. And then each of these, if you think of them as individual tiles, you got these electrically isolated pieces of metal impacting ice and rain all the time. They're going to build up charge and they're going to start sparking. There's only so much charge that thing will hold before it'll start to spark over and try to find a ground path somewhere. So they got to figure out that problem too. So they may have figured out the erosion problem. It's the same thing we had the same problem on airplane propellers for years. You put this leading edge on and it stops all the mechanical erosion. And the problem is you start building up the static charge and the propeller blades sparking over everything, sparking over everywhere, making all kinds of electrical noise, which you don't want, and creating these big discharges to places you don't want. They're going to have the same problem.
Yeah, that doesn't sound great. Yeah.
No.
So is there an opportunity here? So, all right, you've got this, long strip of cobalt tiles on the edge. Can you then link that to something like a segmented lightning diverter, like strike tape? Can you integrate this in? Does this have to suddenly? I assume it probably has to become part of the entire lightning, to ground ecosystem, right?
Yeah, it would. How are they going to connect it? I don't know. I mean, having dealt with that on aircraft for a number of years, it's no fun. Making connections to those leading edges is no fun. A lot of times on a propeller, it's very sacrificial. If the propeller were to take a strike on an aircraft, it's just got to survive long enough to get you back on the ground, because you're going to take the propeller off and put a new one on. You really can't do that on the wind turbine side. So you want to be able to take strikes on these tiles and not have to go replace them all the time, because the reason you're putting those tiles on is most likely because the wind turbine's out in the ocean somewhere and you don't want to go out to the ocean and fix it. You want to put these tiles on and leave it. But it's not just rain erosion you have to deal with, it's everything else that goes along with it. You're in an extreme environment. Lightning is one of those things. Static electricity is another one of those issues you're going to have to find a solution for. And this is where all the compromises come in, and that's where engineers have to make really hard decisions.